In this video, we're going to look at the concept of reversible reactions and equilibrium of a system for chemistry. Now guys, this is very important. This topic an important aspect of chemistry. So ensure you stay to the end of this video so that you understand the basics or the concept behind this topic. Having known that, let's go into the details of the video. So we're looking at reversible reactions. So let's begin by knowing what a reversible reaction is. Now, a reversible reaction is simply a reaction in which the conversion of reactants to products and the conversion of products to reactants occur simultaneously. For instance, let's say we have these reactants, reactant A plus reactant B got converted to this product C and D. Take note that this is a sign for reversible reaction. So when you see this kind of sign in any equation, just know that the reaction is reversible. Alright, so basically reactant A and B can react to form C and D products, or in the reverse reaction, C and D can react to form A and B as well. Okay, so this is basically what you have to know about reversible reactions. Now, note that reversible reactions will reach equilibrium, and a system is said to be in equilibrium. We are looking at a system in equilibrium now. Alright, a system in equilibrium. Okay, now note that the system is said to be in equilibrium when both the forward and backward reactions, either I call it backward or call it reversed reaction. Okay, so a system is said to be in equilibrium when both the forward and backward reactions are occurring at the same rate. Let me say it again. A system is said to be in equilibrium when both the forward and backward or reversed reactions are occurring at the same rates. Okay, now note that equilibrium is only reached if the reversible reaction takes place in a closed system. What's a closed system? Now note that a closed system just means that none of the reactants or products can escape and nothing else can get in. Now, for instance, when you are boiling water in a cup and you close the cup, or when you are boiling water with a pot and you close the pot, that's a typical example of a closed system. Now, note again that the position of equilibrium can be on the right or the left of the reaction. Position of equilibrium depends on the following conditions. Position of equilibrium depends on temperature. It also depends on pressure, and it also depends on concentration of the reactants and products. Concentration, it depends on concentration of reactants and what products. We look into these conditions of equilibrium in details when we get to the Italian's principle. But for this video, know that the position of equilibrium depends on temperature, pressure, and concentration of the reactants and products. And lastly, before we call this a class, know that reversible reactions can be endothermic and exothermic. In reversible reactions, if the reaction is endothermic in one direction, it will be exothermic in the other direction. I'm going to explain this more when we get to Legge Italian's principle, but for this video, just know these basics. Now, note once more before we end the class that in a reversible reaction or a system in equilibrium, this arrow sign here is for the forward reaction, whereas this arrow sign here is for the backward reaction. So take note of the arrow signs, what they mean. Okay, let's call it a class here. I hope you learned something interesting from this video. Now, if you are new to the channel, ensure you check the description of this video below. You'll see a link to our Telegram channel. Click on it and join the Telegram channel for instant notifications. And also ensure that you are subscribed to this channel by hitting the subscribe button for more videos like this. Like, share, and comment on this video. Tell me how you feel from what you have learned from this class. If you seem to have any specific questions to ask regarding this topic, feel free to leave your question on the comment section below, and I will be sure to give you a response. Now click on the end screen above, and I will see you in the next video. Thanks for watching.